In this video, we will try to understand the summary of sign conventions, also called as new Cartesian sign conventions for mirrors. Okay. So first of all, we'll understand these two mirrors, how they look like. We know that concave mirror looks like this, right? Like this caved mirror. Okay. Convex looks like this, correct? Bulged. This is how it looks. Here we are going to take the half of it, this side of it, and here also only this side of it. One thing we have to understand, since they are spherical mirrors, okay, so we'll treat them as spheres. Before that, we will understand this graph. I'm sure you have seen coordinate geometry. When we studied coordinate geometry, this is called as zero or origin. Whatever comes to the right side of origin is positive. Whatever goes towards the left of this is negative. The same thing applies here. Whatever goes to up is positive. Whatever comes down is negative. Same logic we are going to apply here. Okay. So when we observe for concave length, the focal length is going to be on this side, correct? So this we will treat as origin. This is origin for the mirror. So focal length is going to be negative. This is the value. Always focal length is going to be negative for a concave mirror. For a convex mirror, since it is bulged, the focal length is going to be on this side, right? Both center of curvature and focal length is going to be on this side. So focal length is going to be positive because from here it is on this side and from here it is on this side for concave. So focal length is negative for concave mirror and positive for convex mirror. This is something we should be clear, because based on this only power also matters. Okay. Now let's come to the first one. U means the first one is U, which is object distance. Object is always going to be in front of the mirror. It is always going to be in front of the mirror. Therefore, it is going to be on the left hand side only. Whether it is for convex or concave, it is going to be in front of the mirror. Both for concave and convex, the object is supposed to be in front of the mirror. So always in front, therefore always it is negative. Okay, I have mentioned here. The object distance U is always negative for both concave mirror as well as convex mirror. Okay, I hope this is clear. Object, because object should be in front of the mirror. Fine. So let's go. Next one, V. V is called as image distance. Now we know that there are two types of image. One is real inverted, another is virtual erect. Real image means in front of the mirror. What is real image? Real means in front of the mirror. Since it is in front of the mirror, image distance is always going to be negative for real image. Now the opposite to real is virtual. If real is in front, virtual is behind the mirror, correct? The virtual image is behind the mirror. Since in front means negative, behind means positive. That's it, simple. Okay, in front means on this side. This is real image. Virtual means behind this. So whatever comes to this side is positive. This is called as behind. So behind always positive. Here also behind means always positive, behind. So virtual images will always be treated as positive value. So image distance will be positive for virtual image. To remember both together, you can remember this logic. Real inverted and virtual erect. River. Remember this concept, river. Real will always be inverted, virtual will always be erect only. Okay, it can never be possible that real and erect or virtual and inverted. It is never possible. Real and inverted one combination, virtual and erect another combination. So real and inverted, virtual erect, you can remember them together as river. Okay, let's move to the next concept. Object height, h we treat. H, object height, object should always be upright. Upright means what? It should be above this axis, principal axis, correct? A man will be standing here, right? A man will not stand underground and then show the image, not possible. A car will be standing here itself, correct? Car can never be underground and then inverted, then get the image, not possible, right? If a lamp post is there, it will be like this. If a tree is there, it will be like this only, correct? We are going to see the image like this. So they are going to be always going to be above the principal axis, so they are going to be positive. Object height always positive, because it is above principal axis. Now what is the image height? H dash we call. Image height, if the image is erect, that is virtual and erect. Erect means upright, straight. Then it is positive. If the image is real and inverted, inverted means it will come like this. Image will come like this. Like this it will become image. Okay. A tree means a tree will be looking like this. So this is called inverted image. So inverted image means it is always going to be, the height is always going to be negative. Okay, clear? So let me repeat once again. Object distance always in front of the mirror, so negative. Image distance, if it is in front of the mirror, it is called as real and inverted image. It is going to be negative. Virtual, it will be behind the image, so always positive. Image distance for real is negative, for virtual images it is positive. Now if you come to height, height of the object h is always positive. Height of the image depends on whether it is real and inverted or virtual erect. If it is real and inverted, it is going to be negative. If it is virtual and erect, it is going to be positive. If you observe height of the image and the distance of the image, it is positive for virtual and erect, correct? Both image distance and image height is positive for virtual erect and negative for real and inverted. All right. Now comes magnification. Magnification, we know, image distance divided by object distance. Okay. So if say h dash is positive, virtual and erect, it is positive. H is anyway always going to be positive. So for virtual and erect, it is always positive. Simple. And for real and inverted, it is always negative. Simple. Here you observe wherever we are getting virtual and erect, we are getting positive, correct? Only for real and inverted, we are getting negative. Same goes with magnification. For real and inverted, negative, and for virtual and erect, positive. That's it, simple. Okay. Fine. So same thing with m is equal to minus v by u. Same concept, virtual and erect positive, and then real and inverted negative. Same concept. So these are the main Cartesian sign conventions. This is the first step. How to decide whether the image is reduced or enlarged? If magnification is greater than 1, it is enlarged, because object image height will be more, so it will be enlarged. If image height is less than 1, it is diminished. Image is diminished or reduced. What if magnification is equal to 1? Then it is same size. Image is same as object. That's why we get 1. Both get cancelled here, numerator and denominator. We get the same value. I hope this video gives clarity on the Cartesian sign conventions for mirrors. Thank you so much.